Hello beautiful people, welcome back to this channel. My name is Joseph Abba. Today I want to show you 5 tricks to spice up your Go program, and I think you're going to love them. Now if you've not subscribed to my channel, please kindly do so. Alright, let's start with the first one. In Go, when you compile your binary, you can compile to a single binary. That means when you are shipping the program, you want to have one file which is the executable, and ship that. It's a fantastic idea, but then what happened to your asset? Let's say you have migration files, you have JavaScript asset, you have CSS, you have audio, video, anything. Now, Go made it really easy for us to embed them. Of course, it's going to increase the size of your program, but doesn't really matter. The most important thing is you are not leaving anything behind. So it's like zipping everything up. So let's go ahead and create a folder here called 01-embed. And I can create a main.go in here. Let's import embed this way. And I'm going to create a new type. Let's call it to do. And here we're just going to have ID of int, the task we want to do, and if it is done or not, which is a Boolean. Simple data structure, we want to do the JSON, so I can do JSON, so the simple data structure. Now we're going to put a to-do.json here, which I'm going to bring the data from my second screen, and we have the data here, so I need to rename this to to-do.json. all right. When we compile this program, I need a way to bundle this file with the program. So how do we do that? All right, so we can come here and basically do this. So I'm going to say / is like comment. So go embed to do.json, but we need the variable. The data is basically reading it and attaching it to the variable. So I'm going to say the data is bytes. Now it can be bytes, it can be string, and then I think one other data type, maybe, yeah. So we have this way. All right. Now, when the program starts, your to-do.json will be read and populated into this data variable. From there, we can use it. We can go ahead and create to-dos. After that, we just marshal json.onMarshal. We're going to marshal the data is bytes already. We don't need to do anything else into these to-dos that we've created. We just check for error here. Since we are in main, we can do log.theta here safely. Now your to-do already has the data, so we can go ahead and say for to-do range. This is basic stuff. And of course, we just print, maybe we can print to-do.task, just like this. I don't want to print everything, not to waste your time. This we can compile, go to do like this. We just build it. As you can see, there's nothing, no special flag, nothing. We're just going to build it. Now I have built it. What I want to do, I'm going to switch to bash because I have autocomplete there. Now that we've compiled the program, this is a compiled program. Let's run it here and see. You see, we have everything right here. Everything printed here. But what if we move it? Maybe for some reason we move this to a different let's move it to desktop. Move to do to my desktop. And then I can go to my desktop and run the to-do. You see, it still worked. And remember, on the desktop, we don't have the to-do.json there. We can even delete everything here now and it still work. It worked because we've been able to bundle the data directly into the binary. It's a fantastic concept. So thank you for watching that. I'm going to go ahead and remove it from my desktop just to clean up the space. All right. The second trick is, let's say you are solving a data structure problem or some kind of algorithm problem, usually interviews and all that, and you have some data like this. Let's make an int 1, 2, 3, 4, 4, 5, 6, 6. Now, this data we're looking at is not just about a duplicate, but how the duplicate is structured. There are consecutive duplicates like 4, 4, then 6, 6. So it's not just about trying to remove duplicates, but removing the duplicates that are consecutive. And there is a new package in Go called Slice. There is a Slices package. So we can simply use, let me call it compact, which is the name of the function too. So you call this compact and then you pass it the number, and we can go ahead and print it now. I'm going to go ahead and print out like this so we can see the full data correctly. Okay, here we can run the program. 02, right? You see, we need a new line just to make sure. As you can see, we have 1, 2, 3, 4, 5, 6. The repetition that is consecutive are gone. But look at something. Let's say here I come and I put 7. You see, 6 is still repeated. We still have duplicate of 6 in the array, but this is not what the compact is meant for. Now we are going to see the data. 6 is going to be repeated. It has to be consecutive. So if you are solving an algorithm data structure problem and you need to remove consecutive repetition, this is the function that you can use, compact, in the Slices package. Thank you. Go is managed. What does that mean? It means your memory is managed by a Go runtime. So it uses the garbage collector to clean up memories that you no longer use. And each time your program runs, you are allocating memory. That is how your program is able to run. This program I want to show you is basically a way for you to monitor how the allocation or how the garbage collector behaves. Of course, the concept of garbage collection, memory management is complicated. It's something you should spend some time on. If you check the Go documentation, they have very big document to explain it. But what I want to do now is to start with, let's set the bug, set memory limit. Let's set 50 MB as the memory limit for our application. And this can help us see the behavior of the garbage collector. So this is 50 MB, right? Good. Now let's allocate some large memory. Anytime you call make, you are going to allocate memory, and this is really important. So careful with how make works. So our memory limit is 50 MB, but I'm going to allocate 40 MB out of it now. Even when we try to go above this memory limit, it can go above it, but when we try to go above it, what happens is you're going to see that a lot of allocations happen, and if you can avoid allocation, great idea, but it's super difficult to do so. And let's say we're just going to see the printout of how they allocate the memory allocation works and how the garbage collector behaves. So I'm going to do runtime, runtime.gc, and this is signaling to garbage collection that here you can do your thing, right? So I want to print something up here. Print. I think this is probably going to be the longest video or the longest section of the video. Allocate 40 MB. So here, this is where we are doing that, just for us to keep track of what we are doing. All right. Now that we signal to the allocator to do something, what I want to do is I'm going to write a function here called print memStart or something like that, or print memory start. We can name it anything we like. And this is after the allocation. Right, this is after the allocation, but then we need to use this. Basically, what we're going to do after this first allocation, we are going to go ahead and allocate more memory after that. So we can do like loop, maybe 3 times is okay. All right, 3 times is okay. So what I want to do, let me print something out. Print ln, or let's use printf because I need to put something there. Allocation of additional DMB, okay, and we can say I plus 1 or something times 10, okay, and we give it a new line just so that we see it in a new line. All right, now let's go ahead. This is the first allocation. We're going to append to it. We're going to append to it and basically copy, let's say make. We probably can copy this, paste it, but we need to spread it. All right, but this time around, let's do 10 each. Each time we do 10. All right. What's going to happen here is when you go beyond the initial allocation, there is going to be some copying. The go runtime is going to copy memory here and there, and that's quite expensive. So we're going to see the effect of that. And of course, we want to signal again to the garbage collector. And after that, we call this function we are going to write here. I think we can say, let me put something inside. We can say after additional alloc of just something like this, I plus 1, something like this. All right, and then I'm going to sleep for 2 seconds, or 2 seconds is enough. 10 seconds. Okay. 10 seconds we are going to sleep, and after that I can come here and say we are done. Or of course we need to write the function. So all right, let's write this function. Why does it give me? It's interesting how the IDE did this. This is supposed to be a string. Okay, what happened? Okay, oh, right. But why does it assume that? Okay, what happened? What did we do here? All right, I'm going to copy this out slowly, and I can see where we have the error. Oh, yes, the reason why there is an error, this returns 2 values. So, I see where the mistake is. We're using the wrong function. So it should be sprintf. Yeah, that is the disadvantage of typing the code live. But yeah, at least you learn from mistakes. So memory starts is runtime memStart. So everything is there in this memory start thing. So we're going to load the memory statistic runtime.read memStart into it. Okay, there should be a pointer, I think. Yeah. After that, we're just going to print out the data. There's nothing special here anymore. We're going to print out everything that it has. So I'm going to print the label just so that we know where we are. Label is like these things we are putting here, and it's after thing and allocation thing, right? I'm going to duplicate this. I can just put a tab first and say alloc. Alloc is going to equal to v mb. Alright, then what we're going to do here, mem start. I want to show it in MB, so we are going to divide it by 1024, 1024, so we can show it in MB. Alright. What else? We want the total alloc, and the same thing, but here's total alloc. All the variables that we need are in the variable. In everything that we need are in here, so we are not doing anything. The system, this one, system, we want to print what we requested from the system, the total memory requested from the system. That is what is this one. And last one is the number of garbage collection that cycle that have run. So this is it. And then we can say num.gc. So this one shows you the number of garbage collection cycle that have run. Let's run the program and see. Go run and 03. If there are no errors, we see. We can look at the data a little bit. So if you are confused, you can see that we did the first 40 MB allocation. You see, this is the first cycle that ran, and then the total allocation was 40 MB system, and then two cycles of garbage collection ran. You see, this time around it was 90 total allocation again. The copying of data is happening. 4 cycles of garbage collection happen. So you see, it's accumulating. The total alloc is accumulating because copying of data is happening and more allocations are happening. So for this small program, we've had we allocated 230 MB of memory, and then the cycles of garbage collector, 12 cycles were around. The MB shouldn't be there in, this was just a mistake, so it's done. Put this one there. All right, so this is very good for you to see what the garbage collector is doing in your program. It's a little bit advanced, like I said. It takes a lot of time to study and try to understand it. You have to play with it and all that. So that's it. The next thing I want us to look at is race condition. So I'm going to go ahead and create another folder here called 04 race. Now we create a main.go, and let's create our weight group from the sync package. Weight group counter is 0. And what else? We're going to run 2 go routines, so I need to add 2. So weight group dot add 2. When you add, before you run your go routine, you want to tell the weight group how many go routines you want to run. We can of course run it in a loop, but I'm going to just copy and paste it when I do it here. So this func, something like this. So this is going to run. First thing I want to do is to we are going to modify the counter, and it can be 10, anything. The number doesn't matter here. What matters is this counter we are changing. After the loop, we are going to tell the weight group that we are done. And we're going to do the same thing here. This is 2 times, and then we're going to wait for the weight group to receive the done from both go routines, and we can, of course, print out the final count is count. Let's run the program, but this time around I'm going to run the program with this flag race, and 04, right? Printed out that we have data arrays, which makes sense. But the thing I don't really understand in Go is, when you have these data arrays, the error message never really gives you anything. For me, this is quite confusing. It doesn't say anything. It just say that you have data arrays with a lot of memory addresses and pointers and all that. So it can be challenging to debug. Or in order to debug it, of course, you can turn on the debugger and then go through this and see when the Go routines are changing the data. But now here is the trick. Here is how I used to know if a program would have a race condition or not. Concurrency is difficult. When you see in a program, when you see a weight group and some kind of data, it doesn't have to be a count, it can be anything. Anything that is not concurrent safe. If you see that and there is no mutex, you don't see where they are locking the data, or maybe there is a channel that can block the reading and writing, and you don't see mutex, then it is safe to assume that there might be some kind of race condition. That means you want to run the program with this dash race. If I take out this flag and I run the program, you see, it says 20, the count is 20. It keeps saying the count is 20, which, it sounds like it's correct, right? But there is no guarantee that this is going to continue to be 20 all the time. There's possibility that this number can change because the writing is very bad. So here is how we can fix it quickly. I'm going to try to fix it. So I'm going to put a race here back, and then we still have the race condition. So what do we need? We need some, I'm going to say M here for sync.mutex. So take a mutex, and then we are going to come over here as well, and then mutex. I can say mux, something like this. Sync.mutex is coming from here, right? Okay. And what we are going to do is to pass it just pass it like this, and we run the two of them. But this time around, let me go back. Before we change the data, I'm going to lock it. m.lock. Some people use defer here immediately, but I don't want to defer since I am doing here. Immediately, I want to do the entire loop first, then I can unlock it. And this is it. This is going to lock the data. This is the critical part. It's going to lock it until we are done with the loop. Now we can run it, and there shouldn't be any race condition anymore. You see, it's gone. It's gone because we are now protecting the critical part, which is where we are modifying the data with a mutex. So this is the fourth trick. Last one. So let's create 05-func. Right, 05/func. So what are we building this one? Imagine if you come from PHP or some other dynamic language, it's possible to run, let's say, you have a function, let's say call func, something like this, and you give it the name of the function, let's say add, and you give it some argument. We can say interface or something. We just give it some argument, interface, for example, and and it can run this function. But how do you do this in Go? Well, welcome to reflection. Let's work on something like that quickly. Reflection is a powerful programming approach, but you don't want to overuse it. Honestly, you should only reach out for reflection when you have exhausted all your options. So don't forget that. So let's call this call func, something like this. The name of the function we want to call will be string. I'm thinking maybe we can write two different versions of this code. This one I'm writing, and then the return type can be interface. And this is the downside to this. Each time you use this interface data type, you lose out on static analysis. Your program, your IDE and all that, they are not able to tell the data type that you're really using. So it's not very good. But what I want to do is I'm going to cheat a little bit, just going to cheat. We are going to predefine the functions here as a map. There's a reason why I'm doing this, and we can write another version that doesn't do this the video is not too long. So I'm going to do this, right? And we can say, let's say the first function is going to be called greeting. We don't have the function yet, so greet. And then we're going to have add, and then add, right? Like I said, we don't have any of these two functions yet. Maybe we should go ahead and create them as well. Greet, name, string, and I can just print something out so you can see both behaviors. Font, it will be hello name. That's it. Add is going to return value. Func add ab int return a plus b. All right, simple stuff. Now that we have those two, we can find the function that we want to run, and from the map funcs, we just get the func name. We pop it in here. If we don't find it, we want to, what should we do? I'm going to panic for real. Func not found, something like this. Since we are not returning an error, so we can panic. Not a good approach, but hey, I just want to show you reflection. So the function value, this is where reflection comes in. We are going to turn it into a reflection object called value of. Value of allows you to transform an object into a reflection object, so you can query it. For example, because we have this now, we can do something like this. So let's also transform the argument. Make. We are going to make value len. The reason why the len is important here is to know exactly the memory you want to allocate. We just look at memory allocation now, so you don't have to reallocate the memory. So this is very good. Arg range args. So we are transforming this now in at index I. We want to add reflect the value of, okay, and then arg. This one gives us arguments that are all reflection objects and the function as well. So this is it now. Result this one dot call. Very simple. And then you pass it the argument. And we can of course check if there is any result. Len result phase 1. We're going to return it, right? Interface. If not, I think we can return a name here. There's nothing was returned, we just return name. Okay, so this is the code. The takeaway for you is this: reflection, you can convert any object into a reflection object, and that helps you to query, to do many things. It has a lot of functions. Like, it has a lot of functions that you can query. If it's zero, if it's valid, if it's a method, if you can do so much with it. Now that we have that, what next? Let's start with the basic one. Let's call what greet. We can go call greet with Joseph. That's my name. And of course, we want to bring out the bash go run 05, and if there are no func not found, so let's look at the map. Maybe we named it something else, greeting. Okay. And we pass the correct function. See, we've been able to execute that function dynamically. It's a very powerful thing. Dynamically, we've been able to execute that function. What of the add function? We have add, and we can interface I think we have, sorry about that. I want to pass it, let's say 1010, yeah. But here, because we want this in an int, I can say result here, and we can convert this into an int and print it. And say result and result. Right, so this is correct. Okay, so we run it again, and you have 20. So as you can see, we're able to run this function dynamically. We can pass arguments, we can convert it, we can do anything we want to do. And this is a powerful idea. Imagine you are building like a plugin system and all that. Reflection is your go-to. Or some of the ORMs are using reflection as well. So this is what I have for you for this video. But then one last bonus. I want us to rewrite this function to take out this map. Let's rewrite the function 06 and then call user func. If you have done anything in PHP, I want to bring out my call user func array. There's a function like this in PHP that you can use to call user function, something like this. So you give it a function you want to call and an array of arguments, and then it goes ahead and help you call the function. It's very powerful. So let's sort of rewrite this function to behave like that a little bit. We're not going to support everything, but I think we can do something. So func call user func with args. Alright, so this is the function we want to call. We're going to use an interface here again. Args is going to be a slice of interface. Okay, and then return value. In the PHP version, it returns two values as well, a false a false to signal like an error state, then the result. So Go allows us to return multiple values. So we're lucky here. Now let's work on it. The same thing we did earlier, probably simpler. Reflect. So I'm going to say value of the function. All right. We convert it to a reflection object. Now here's where we're going to do something a little bit different. We're going to check, because we only want to work if we have a function. So if the reflection object is kind is not equal to reflect dot func. So if it's not a function, we want to return nil, but we also want to return errors dot nil, not a function. Something like this. You can use like a format the error message a little bit to include the function in here, but we don't have time for all that. So the same thing we did earlier, maybe I should just go ahead and copy that over this one. So I'm going to come here. This is the in, this is the argument they are bringing, and we're doing the same thing. Then the out, which is the return, we are going to do the same thing now. Call, we pass it the in. What else? We're going to check. If it's 0, that means no return type, no return from the function. Else, we do the same thing. You see, it is very similar to what we did a while ago, just a few minutes ago. return dot, this is interface, right? And then the error will be new, okay? Now this can panic, but we don't really care, it should panic. Now that we have this is more flexible, so we can go ahead and test it with, let's say, I can do, let me copy these two functions that we have here. Let me copy them over. Okay, so we have the greet and add. You see, we're no longer using the map. Let's start with the greet. I can put this greet in, greet, and we have this interface. So we are going to greet Joseph with it. We can run the code now, 06. You see, it works. It called that function, this function for you, and pass the argument. What of the add? Let's do add. So instead of Joseph, we are going to add 20 and 30, making it 50. Let's see what happened. Sorry, this one returns the data, so we can do this like this. If error not name, I'll panic with the error. Else we print the data here. 50. You see, printing of the data, I want to structure it a little bit different. Let me use printf. I want to use the v flag. Something like this, because I want to do something more, a little bit special, to show you how powerful this is. So we need a new line here. Right, so 50. Now, what if we change it, do a more complex data structure? So let's do user struct name string func. It can be print names, and it takes users, takes an array or a slice of user. If we want, okay, let's just do the usual loop. Range users, and we can print each user in a new line. The good thing about this is that we are still using the type. So here I'm going to come and say var, or we can do it in line. Users, this is a slice of user, and then user like this, name, John and Jane. We can have Lizzie or something. Lucy. All right. So we have this data. It's a more complex data structure now. We pass it the function, and we give it the data. It accepts a single argument of that slice. So nothing is going to be printed here, since it's return name for function that doesn't return value. So we should have that name, but look at, we have it complex data structure printed out. It's a very powerful idea, very flexible. Takeaway for you is this: you can wrap any kind of variable in a reflection object and then inspect it. For example, we are checking if the kind is a function. It has the way to check if it's a pointer. I think PTR, yeah, exactly. So if this is a pointer that was passed or something, you can do a whole lot with it. But like I said, reflection should be your last resort when you have exhausted all your options. So thank you so much for watching this video. All the tips or the tricks or the wonderful things that we've learned in this video, kindly leave a comment if you enjoy what we have learned today. Thank you. Bye for now.